In this recording, we are going to discuss number 23 in the Statistics 1, Math 1 to 2, Unit 6, Assignment 6. So it says, the random variable x approximates a normal distribution with a mean of 63 and a variance of 8 squared. And the probability that x is less than a certain value is 0.1401. Find the value of x. So here we are provided with the mean and the variance, and we are given a probability value. So we have to find the value of x. So as we can see, the 0.1401 is a tail, okay? And as we discussed already, the normal curve that we are using is calibrated for big chunks. Let's take a look at it again. So by now we are familiar with this table that we are using. And as you can see, it is calibrated for big chunks. Here it is, phi of a positive value of z. And as you can see, all the property values are actually 0.5. All right, no less than 0.5 because this is that big area there. Now, in this question now, we are given a tail. As we can see, 0.1401 is a tail. We cannot go into this table with 0.1401. We must do 1 minus. We must subtract 0.1401 from 1 in order to go into this table so that we can get our z. Let's look at an example similar to this question. So if we go to Unit 6, example 5.11, you can get this example on page 22. You will encounter an example similar to the one that's on number 22. Here it says, sociologists claim that the mean time that Dominican teenagers spend per day speaking on the cell phone is 90 minutes. So the mean is provided with a variance of 25, and the variance is provided, that's 5 squared. All right. Now, Jeffrey was told to calculate x. So you see, this x, just like number 22, you are required to find x. Given that the probability that a randomly chosen student spend more than x minutes on a cell phone is 0.1611. So as you can see, you are also provided with a probability value less than 0.5. Okay? The only difference there is that this question is shaded towards the right because it says more than, so this is a right tail, whereas this one is shaded towards the left, so this is the left tail. So when you sketch in your curve, because you must sketch your curve to represent what values you are doing, unlike this example that is shading towards the right, you will be shading towards the left. All right, the tail towards the left. And your mean value will come right there. In this case, this is 90. The mean value there is 63. Okay. And then you'll be standardizing. 0 will take the position of the mean. And then you have to apply the formula x minus the mean over the standard deviation. That's why here they have to square root 25 because the formula for z is x minus mu over sigma over the standard deviation. Now the variance was provided, so that's why they have to square root there to get 5. In this case now, the variance is 8 squared. The square root of 8 squared is 8. Okay? So whereas here you have x minus 90 over 5, here you're going to have x minus 63 over 5. Now, as you can clearly see, here you have the algorithm. You are standardizing from x to z. And here you can clearly see the 1 minus taking place because as you can see, this table does not give you tail. This table gives you big chunks, phi of positive z's. All right, so we need to go into the table now to get the z so that we can find what is x. Okay, we can use this formula to find what is x. So if we can get z, then we can do some simple algebra and to get x. The z is found in this table. To get Z, you can use a probability value to get Z. As you can see, the probability value for this example is 0.1611. 0.1611 was subtracted from 1 to get 0.8389. And with 0.8389, all right, the example went into the table. You go into the table and look for 0.8389. 0.8389. As you can see here, it is. And the Z value is 0.99. Okay. That's why you have here 0.99, that's Z. And then you can simply apply some algebra to solve for X. As you can see, X will be greater than the mean because X is on the right side of the mean. However, in our example now, X will be on the left side of the mean. X will be a value smaller than the mean. Now, this table is not calibrated for negative Z's, but remember we're in a left tail. So after you subtract 0.1401 from 1 and you go into the table and you get your Z, you've got to put a negative sign by the Z, okay? So that when you do your algebra, you'll be getting a value smaller than 63, okay? Because this is a left tail. Left tails are on the left side of 0, okay? Here is 0 there. Left tails are on the left side of 0. A number on the left side of 0 will be a negative number. So you got to attach a negative sign to Z so that you can find the X value that is less than 63. There are some algorithms there in this. If you leave it out, you will not be penalized. Okay. These algorithms there are not totally necessary for you to get your final answer. These are just formalities. Okay. Once you subtract your tail probability from 1 to get the big chunk, you use that big chunk to go into the table to get your Z value. And for this question of number 22, you attach a negative sign to that Z value. And then now you solve for X by using this formula there. X minus the mean over the standard deviation will be giving you your Z value. So you'll have the negative Z and you will solve for X. So this example number 5.11, you can use it to help you solve question number 22. Number 23, sorry.